So first of all, I want to talk about the cloud promises. So now we are in the time not talking about, hey, cloud or not cloud. So cloud do deliver good things. So first of all, the deployment agility, what I mean by that is from the concept, the service provider take care of the infrastructure, and they take care of the complexity of the underlying infrastructure. And so the business owners, the cloud adopters can focus on their core business. So it really provides the agility to do the innovation faster. And in the cloud, it's supposed to run everything like automated. So it provides the operational efficiency and also eliminates the human error. And also this characteristic of the cloud called elasticity, so you can auto scale your workload based on auto scale your resources based on your workload. So you have a small workload, you can only use an amount of resources. But if it's the peak of your business, then you can rapidly scale it up. And also, it also brings the high performance, meaning the CPU, GPU that's sitting in the public cloud. Now, even I'm a small business owner, I can leverage the high power computing resource from the cloud. So it really significantly lowers the barrier for those cloud adopters. And then if we can achieve all of them to deliver the best user experience with the minimal resources, then we are not far away from improving our ROIs. But that's ideal world. And in the reality, we know it's very hard to achieve all of them. So what are the cloud infrastructure challenges that we observe? So first of all, good thing for us, the networking is not going away with the cloud coverage. And it's not only not going away, it's actually the complexity becoming more dramatic. The reason being now so traditionally it's all like monolithic software, but now it breaks down to single function service that's well-defined, the operations and interface, someone called microservice. And each of the service needs to talk to the underlying resources, which is all over the place. And also the microservice, they themselves needs to talk to each other. So this kind of communication really significantly increases that complexity of the networking. The second point is really about in the cloud, you're supposed to launch an instance right away or kill it if you don't need it, and it's all automatic. But without having a big picture, you might just kill something other ones is using, or you spin up something that's maybe other team already have the service, and you're duplicating those service that's wasting the resources. And these kind of operations cause the unpredictable app performance. And furthermore, the multi-cloud adds the more complexity onto it. So many cloud adopters, especially those big ones, adopt the multi-cloud strategy for different reasons. But primarily, they don't want to be locked in by a certain vendor. And today, if we want to manage the multi-cloud environments, we have to go into different console and config separately. And that creates the silos and adding the management complexity out of it. So now when we see the problem, we have to see it and understand it and fix it. So what's the problem? What's the challenge we see with the traditional monitoring tool? First of all, those traditional monitoring tools are pre-cloud, not mentioning those are in the hardware appliance form factor. You cannot just put it in the cloud and plug and monitoring your cloud. Even for those which are in the software form factor, they are probably only good for monitoring your traditional workload, but not the modern cloud deployment infrastructure. The second one is about Google, Amazon, Microsoft, those cloud giants. Yeah, they do provide some kind of network analytics, like they expose the VPC flow to the general public, but they don't really have if they want to go deeper, they don't do that. The analogy I always use is if I always go to my family doctor to do the general checkup, but if something really wrong with my eyes, I need to see an eye doctor, right, who has a specialty on that perspective. And the third one is somewhat related to the security tools in the cloud today. So a lot of tools that we see is more focused on meeting the compliance for the workflow of the security operations center, rather than focusing on the operational part to have to get the actionable insights for the operators.
And the flow logs in the cloud came from the firewall logs, forensics, and Sumo Logic, Splunk, some of the more security SIM-like tools. They're bringing that in, but don't have a lot of the infrastructure context. And so that's just what we've seen in our customer base. They're great tools. People are going to use this data multiple ways, but there's different tools for different groups.
Yeah, and from the use case perspective, to better manage the cloud, and we see customer facing this kind of problem. First of all, the performance. The performance I mean here is really the application performance plus the networking performance. Much of the time when issue happens, many people don't know if it is because of our network or it's something wrong with our application. And it's not only about the currently running service and we can get into the root cause quickly. It's also about building and evolving the cloud infrastructure that generate the best performance, which aligns to your business goals. And second is the cost management. So this is a big piece. We've heard a lot of customers caught in surprise when they got their first cloud bill. And there's actually a lot of things that they may not know can cut down their cloud. Like, you can eliminate your inter VPC or inter-region traffic rather than deploy in your VPC. And then the third one is the security. So in the cloud model, it's a shared responsibility model, meaning while the service provider take care of the security, protect your cloud infrastructure in a much lower level, you as a business owner, you're responsible for protect your application and the data. So with those layers of security responsibility, it's really hard to have that confidence to say, hey, I know I am fully protected in the cloud. So how Kentik can help? So this is another kind of, the overview of Kentik platform, similar to what Avi just showed you. So on the left-hand side or right-hand side, it's about the data input. So you can see we're talking about the multi-cloud and the hybrid cloud environment. So we get the data from your on-prem data center infrastructure and the public cloud, wherever your workload is at. And beyond that, we also can consume the data from the container orchestrator tool like Kubernetes and the service mesh tool like Istio, and we get consume the tag and label information, which contains the information about your info about your infrastructure, your service mapping, and your users' information. And with that, we have the data inject to the Kentik platform. And on the other side, we support a lot of interaction with the third-party tools in terms of automation and notification. And also, Avi mentioned, we have very rich of API sets, which provides the strong capability of programmability. And the cloud portfolio, what we mean by cloud portfolio, it's really about the types of data that we acquire and the type of analytics that we do with those data. So on the top, it's really it's the flow logs from different cloud provider. So today we support the GCP flow log and we support the AWS flow log. Like they do have implementation nuance between them too. And also in the early next year, Q1, we will have preview for the Azure. Beyond flow logs, if you want to get more, because Kentik can do before the cloud, we do the host level instrumentation, and we look into the network device like router and switch. And now we can extend that monitoring capability from the on-prem to the cloud. So those are all the things that, all the raw data that you can grab from your infrastructure. And also we can consume the data and labels, as I mentioned before, that give the context of those, the data that we pull. And this is really a zoom-in view of what I just talked about. We have different data sources coming from the cloud to the Kentik platform, and we enrich those flow data with the tags and labels information for the infrastructure service map and so on.
Crystal, quick question. So this feels like a bit of a departure from what Kentik has traditionally done, ingesting huge amounts of records and correlating those records for service providers in how we spent the first part of this presentation. This feels like an enterprise tool. So was someone asking for this, or did you guys just see a market opportunity and said, I think we can get into that space?
Yeah, I think that's pretty much like a marketing-driven decision, because the cloud becomes so huge, and we have the expertise of monitoring the big scale of the data on the internet, and if we can, and we see that those challenges that I presented earlier, multi-cloud, hybrid cloud, and if and I don't think there's now have one like unified view provided for a customer to have the to troubleshoot the cloud and to see how I can evolve my cloud infrastructure to a better stage.
There was a customer-driven component of it certainly too. I mean, there's the side of Kentik's customers that were CSPs, right? But then also the web scale companies, the Pandoras and Boxes and eBays and whatnot, and all of them are saying, well, we're moving certain parts of our infrastructure to the cloud, and we are really missing the level of visibility that we had when all of that was in our traditional physical infrastructure. Can you help us, get the same type of zone to zone or cloud to on-prem visibility that we are used to having when everything is within owned infrastructure.
And you guys going to be showing this?
Well, yeah.
Right now.
Right.
We're going to skip the use cases and show it to you. And just the other thing is, using our APIs, bringing in the business data, that's something most of our customers do. But what we saw was a lot of our customers wanted to do cloud monitoring, but the developers control the images. And they couldn't get the host monitoring they have in their classic data centers that generates flow into the images to account for not having anything. They don't control the switching and routing layer. So unless they have a VMX or a Virtual Cisco or Arista, which is not the majority of the footprint we're seeing, it was on us to do the log integration. So we had people that wanted to do it, but until they were telling us we can't get there, even though the cloud logs are not as good in some ways. It was just something that we were needing to do to make it possible.
So I'm going to rely on all of you here and people on the live stream as well to be my test traffic generators for this demo. So if you wouldn't mind visiting sockshop.gcp.kentik.io and adding some items to your shopping cart and clicking around on the site.
And this is a standard, Weaveworks supplies this as a reference Kubernetes application you can deploy. So we've put it as part of our demo environment.
Can we buy anything we want?
You may.
Sock shop. Does somebody have a credit card?
And we have been asked if we could buy your T-shirt as well.
Hey, yes, if you go to our website,
Based in the stock also.
there are socks in the back for folks here locally, but yes, if folks are interested.
They're already delivered?
What's that?
They are already already delivered?
I don't think we have T-shirts here today.
No.
Do we have T-shirts, Michelle? No,
what
just
I
socks.
We'll send T-shirts.
we'll
We have
send
TCP/IP
T-shirts,
socks.
If you want to send a tweet to at Kentik Inc., right? At Kentik Inc. We'll.
Ooh, buy 1,000 socks, get a shoe for free.
So very quickly, for this demo, I have inside of GCP a Kubernetes cluster running with 9 nodes in it. We have VPC flow logs enabled for the VPC that's associated with this. All of the stuff you'll see here works just as well with standard VMs, but a lot of people are using containers these days, so the demo is kind of oriented around that. We have deployed into that cluster the Weaveworks Sock Shop demo Kubernetes application, which is pretty cool. It's a microservices-based e-commerce site that you guys are all visiting now. They've got deployment instructions for a whole bunch of different container orchestration. It's really as simple as a git clone and a kube control apply, right? And then you've got a sock shop demo app up and running. So you guys are looking at this now. You're clicking around on the sock shop site. And then inside of, I'll switch this again because we decided
80 millions of
that
stock.
the,
You got 80 million?
$80 million of stock.
How many shoes do you get for that?
I don't
list of
know.
that?
I know the
You
The
did it for
feel-
the shoes, right?
the feel for the quantity is. I cannot even see how many stocks.
So we have inside Kentik now the ability to provision cloud infrastructure as a data source. The integration for GCP and AWS is a little different. For GCP, you send your VPC flow logs into a pub/sub topic that Kentik can subscribe to. We have a proxy that runs in GCP that will subscribe to the topic that you create and then export all that data to Kentik. For AWS, the flow logs go into an S3 bucket that we can pull from. Once you set up that integration, the devices or the VPC subnets appear as devices, as like sort of virtual network elements inside the Kentik UI. And then we have a bunch of pre-provisioned dashboards that give you some basic high-level information about what's happening within your GCP or AWS environment. So one of the cool things about the flow logs from Google is that they contain built-in latency measurements. So we can aggregate over things like zones and VMs and project names and give zone-to-zone, region-to-region latency measurements. And these are based on the actual traffic present in the environment. There's no synthetic testing going on here.
So we're still at the network level here then. We haven't gone down to an endpoint level, like a specific container that's operating a microservice?
Not yet, but I will get to that shortly.
Oh, okay.
That's the service mesh part.
Aha.
So so these are a bunch of nice overview graphs for those types of things. Then I can look at I was looking for. So I can drill into a Sankey diagram of project, source region, dest region, dest project. And so one of the things that customers have been very interested in is, like Crystal mentioned, when I get that bill that has that big line item for inter-region traffic, people want to know what's causing that, like which instances, which services are responsible for all of this data transfer cost, which can be very expensive in cloud environments, like maybe 10x what you're used to paying for IP transit of a similar amount of data. So I could add on dimensions to this, like I want to see the source and dest VM names, not just the regions and subnet names. So I can run the same query, and now I've got nodes in my Kubernetes cluster. The node names are kind of long, and they don't display so well on this map. But
and of course, you're getting history there. So if it's a transient container,
right, I could turn this into a time series graph and go back in time.
Yeah.
So then on top of the kind of standard GCP elements, we did an integration with the Kubernetes API that's available that maps all of the pod IPs to the pod names and the namespaces within that cluster. So now I can get a map of kind of the pod to pod and service to service interactions within that cluster. And I can see that as a Sankey diagram. So if I mouse over the catalog service, I can see that it's talking to the front end service. If I mouse over the front end, I can see it's talking to the Istio ingress gateway service, all of those sorts of things.
And all this works on classic data center, private cloud. This is just an API integration, getting those tags, building the routing tables as we get the flow. The same thing with the Istio side. So it'll work with, that's part of the what Crystal was talking about. The provider-specific tools are really focused on their own environment. And a lot of our customers, the promise of cloud native and microservices and Kubernetes and CNCF and Istio is to finally get free of one particular cloud infrastructure. So it remains to be seen how much that will happen for everything, but it's definitely happening some.
There's a use case for this with SD-WAN as well, especially with service chain, trying to figure out just where the heck all the traffic flows are going. And
Yeah. Our struggle with SD-WAN has been half the providers want to be an analytics provider, which is sort of the same problem as with the CDN, with the cloud. So, but there are definitely some where we get it, and then it's a question of what orchestration has that data.
Yeah.
Right. How does it open?
So I just added a filter here so that we're looking only at the services, the pods that run within the sock shop itself, and I've filtered out all of the Istio and the services that are associated with the cluster. And it's nice to get a bandwidth graph so I can see, what is the traffic, the service to service traffic volume. But maybe what I'd be more interested in is like a latency graph, which will help me pinpoint the, what are the sort of long poles in the tent of the performance of this application, right? So now the bars and the bands are representing the, that comes up really small, but it says it's 42 milliseconds for the catalog band and 12 milliseconds for the carts band. A UI feature that we added recently is this concept of bracketing. So I can colorize the stuff we're displaying on the UI according to different bands. So I can say, anything up to 20 milliseconds is A-OK, and if it's between 20 and 40 milliseconds, then it's it might be of concern. If it's over 40 milliseconds, then definitely bad. And so now when I add bracketing to that, it's going to colorize the interactions that I might want to zoom in. And I can do this with a matrix too. Back on the dashboard, there's a matrix of source pod to desk pod, and all the cells could be colorized with the latency measurements to point out the things that I might be concerned. So on top of the VPC flow log integration, we also have kind of in beta a integration with Istio Metrics. How many people are familiar with Istio as a service mesh? A little bit. OK. So Istio is like a sidecar container for the pods that run in the Kubernetes infrastructure that acts as a proxy for all of the traffic in and out of the each service in the cluster. And it provides encryption and load balancing and also metrics. And so we've written a connector that can take the metrics from Istio and turn them into flows that we can ingest in our platform. So now we'll see all of the here's all the traffic that you guys have generated, or the people on the live stream visiting the sock shop, and we're getting this out of the service mesh, which gives us these latency measurements, but also application layer details. And so now we can see the latency per URL for the traffic that's going into the front end pod in that Kubernetes cluster. And it provides a nice way of sort of natively instrumenting all of the pods or services that might run in a cluster.
Jim, how hard was it for you to add Istio to the sock shop demo?
It was fairly straightforward. It was kind of like how to add Istio to a Kubernetes cluster step by step, right? So it's really designed to be a bolt-on to any service that you would run there.
Because this is something interesting for private data center as well, which is if you have microservices, containers, systems, applications that are orchestrated with Kubernetes, you can deploy Istio. It really drops in. You don't have to configure policy and get latency data out of it that you can actually use to look at the network. And it's been the holy grail. How do you get the actual traffic performance without having to do a whole bunch of instrumentations? We've been harping on the switch vendors to do it, and it only goes into titration right now with a switch that really isn't very popular. So getting it up the stack, if that's where you need to get it, this can be an interesting source of data for network operations.
So the other thing that Istio does is it provides a fault injection mechanism. So I've got, in the service manifest here, I've got a match on one specific URL in that sock shop. And before I'd been injecting 1 millisecond of latency, but we'll change that to 1 second of latency for that particular URL. So now, if you would all go to your shopping cart page and hit refresh for me a few times, we should momentarily see that the latency indicator for
this is where we put in our credit cards, isn't it?
right. So, when we were looking at this dashboard before, all of the highest latency URLs were the things that required some dynamic page content, right? Address, cart, tags. All of the static content, very low latency, the CSS, the JSS. But what we should see in a second here is that the basket.html URL is going to zoom up to the top position. You can see it over here on the time series graph already. Now, because we're injecting that latency for that one specific URL, that comes right out of the Istio service mesh that's on top of the application that's deployed there. And we get that, per that application layer latency metrics that we can ingest, show on a dashboard, generate alerts from, all of those sorts of things. So there's I think there's a lot of benefits here, both for the what we think of as cloud, right? The public cloud infrastructure, understanding the traffic flows region to region, instance to instance, but now the cloud native, like how do we instrument applications inside these containerized environments to understand where the performance problems lie, and
We need to
yes,
move on. So. But we can see if it turned red first.
Yeah, now now that one URL has
We didn't bracket
zoomed up
it,
to
so
the top.
it didn't turn red, but.
I should have bracketed
Yeah.
it, yeah. And you can see on the time series graph that line